Hi and welcome back. In this lesson, we'll explore required and quoted margin measures to effectively evaluate floating rate bonds. In the previous lecture, we saw that a bond trades at a yield to maturity that can be expressed in terms of a spread versus other yield measures. Particularly, we saw the G-spread is a measure of credit risk versus the benchmark government bond. Given a bond's yield to maturity and the corresponding in terms of maturity government bond yield to maturity, the difference between the two is a measure of credit risk. The higher, the riskier, and vice versa. Another measure of credit risk is the I-spread, for interpolated spread. Remember, not to be confused with the interpolated yield to maturity. This is a spread that is a difference between a bond's yield to maturity and the same maturity standard swap rate. This is a more common measure of yield used to price euro-denominated corporate bonds. And at last, we saw the Z-spread or Z-spread, which is the constant spread to be added to the benchmark government bond spot rates to have the bond's market price. You should also remember how we calculated the Z-spread by iteratively changing the spread so that the present value of the bond's future cash flows, namely the coupons and the par value at maturity, are equal to the bond price. In this lesson, we'll distinguish between the quoted margin and the required margin, and we'll calculate the second, the required margin, using an Excel's add-in called Solver. Solver will do what GoalSeek does and much more. And it's worthwhile taking a look at it because it's very powerful. The basic formula we used in one of our previous lessons is the one we used to price a bond on a coupon date. We can still use it, though in a modified version, to deal with floating rate bonds by replacing the constant coupon C with the sum of two components, namely a market reference rate R, like Euribor, and a quoted margin or spread S. So R, the market reference rate, plus S, the quoted margin, times the face value we assume to be 100 are the coupons. M, in the equation we're looking at now, is the periodicity, with 1 for annual, 2 for semi-annual, and 4 for quarterly. In the denominator, the discount rate is given by the sum of two components, R, the market reference rate, like Euribor again, and Q, the required margin or required spread. Just a quick heads up before we begin. Make sure you have the spreadsheet, the notes, and the slides ready to go. Before sharing my screen with you, I'd like to point out that the first simplifying assumption we're going to make is the fact that we'll be valuing the bond on a coupon date. That is, there's no accrued interest, and we'll have n evenly spaced periods, and the second is that the day count convention is 30/360, so that the periodicity, m, is an integer. The other simplifying assumption we're going to make is that the same market reference rate R is used for all cash flows. However, we can build the intuition around how a floating rate note or bond works fairly well. Floating rate notes differ from fixed rate bonds because the coupon payments vary from one period to the other depending on the level of the market reference rate. An issuer's base rate will adjust automatically to market conditions, and investors bear less price risk since floating rate instrument prices are more stable when market interest rates change. The reason why floating rate bond prices are more stable is that their coupons adjust with changes in market reference rates, whereas for fixed rate instruments, their prices change in response to fluctuations in interest rates because their coupons are constant. Now, I share my screen with you. Let's have a look at this summary about the Serifer's floating rate note issue. Note how interest is stated: 6-month Euribor plus 100 basis points per annum. The market reference rate, in this case Euribor, is usually a short-term money market rate, and normally the interest payment is made at the end of the period, whereas the reference rate is set at the beginning of the period. This structure is called advanced set settled in arrears. So the nearest coupon payment is known at the beginning of the interest period. The next, the one following the nearest coupon date, will be known only at the beginning of the next period, when the previous coupon payment is made. Most floaters follow the day count convention for determining accrued interest of actual 360 and actual 365. And for most of them, a pre-specified spread or quoted spread, as we've called it before, is added or even subtracted, like for example in rare cases for some AAA prime issuers. In our case, the quoted spread for this serifer is 100 basis points, or 1%. The quoted spread S, or quoted margin also, is to provide the investor with a compensation for credit risk implied by the difference with the market reference rate, in this case the 6-month Euribor. The required margin Q, or required spread also, is the yield spread sometimes under the market reference rate, in this case Euribor again, so that investors are compensated for bearing credit risk versus the market reference rate, and can be different from the quoted margin. In this case, of the serifer AG notes, at the time of the issue with a price of 100, the required margin is 100 basis points. We can say that because the issue price is 100. If there's no change in the credit risk of the issuer, serifer AG, and the required margin remains 100 basis points, the bond price on the coupon date will be priced at 100. But if the required margin changes because of changes in the credit risk of the issuer, the bond price on a coupon date will be priced at a premium or at a discount. Similarly, between coupon dates, its flat price will be at a premium or at a discount if the market reference rate, Euribor in this case, goes down or up respectively. But on coupon dates, the floating rate note will be priced at par if the credit risk has remained unchanged. Since the quoted margin is fixed and doesn't change, any change in the credit risk of the issuer will impact the bond price because, for example, if the issuer's credit risk increases and the required margin demanded by investors increases to 150 basis points, the serifer note would still pay a coupon that, on an annual basis, is only 100 basis points greater than Euribor, and thus would be deficient by 50 basis points. Investors would buy the bond below par at a level that implies 50 basis points more versus the quoted margin of 100. The discount would be the present value of the 50 basis points deficient payments for each period. Notice that I'm referring to basis points on an annual basis, however. To fully grasp these relationships, let's have a look at my spreadsheet, where we're pricing the serifer AG note on a coupon date on July 1st, 2022, namely after 2 years from the issue date. Thus, now we're dealing with a 2-year time-to-maturity bond. Do you remember the simplifying assumptions I mentioned earlier? We're valuing the bond on a coupon date. There's no accrued interest, and we have 4, in this case, evenly spaced periods. And the second is that the day count convention is 360, so that the periodicity m is an integer equal to 2. The other simplifying assumption we're going to make is that the same market reference rate R is used for all cash flows. Suppose now we're pricing this 2-year semi-annual floating rate note that pays Euribor plus 100 basis points or 1%. Suppose also that Euribor is 1.25% and that the margin required by investors is 80 basis points. I have decided arbitrarily to start with 80 basis points. Pay attention to the input values in blue. I know it doesn't show much, but as I said in another lesson, I wanted to make these spreadsheets so that they print nicely. And blue prints nicely, both in PDF and on paper. Now, if we use the equation displayed at the top, we get by column. R is 6-month Euribor and is constant also for future periods. One of the simplifying assumptions. S is the quoted margin. The coupon is given by the sum of the 2 divided by the periodicity, which is 2, and times the face value 100. Since the required spread set by me is 80 basis points, we get for a discount rate per semi-annual period 1.125%. This is the sum of 1.25%, the market reference rate, and the required spread, 1%, divided by the periodicity, 2. The column containing the cash flows takes into account the face value at maturity, at the end of the 4th period as well. And at last, we've got the present value of these cash flows. By definition, the sum of the present value cash flows should equal the market price, which in this case is given by 98. Suppose we've got a quote of 98. The question is, what is the implied required margin Q given the bond price of 98? Recall I said earlier, I've set arbitrarily the required margin to 80 basis points. To answer this question, we need to use goal-seek, the Excel function we've already seen. We could use goal-seek, though I want to show you another and more powerful Excel tool, the solver. Solver does what goal-seek does and much more. I want to show you the solver because it stores the input values, and whenever we need to use it again on the same worksheet, we already have the input values set, and we don't have to enter them again. Solver is an add-in that's probably not set on your installation of Excel. To install it, follow my instructions. Go to Data, and on the far right of the window here, you have this button, Analysis Tools. Press it, and then select Solver Add-in. Et voila! Now, to use it, follow again my instructions. Press this button here, Solver. Make sure your cursor is in the input field Set Objective. Delete whatever is in there, if any, and select with the mouse arrow cell J36, containing the difference between the market price and the sum of present value cash flows. Beneath the Set Objective field, you see this 2 and then max, min, and value of. Select the last value of, and then next to it in the input field, leave or enter 0. Now we should tell Excel Solver what to change. The required spread. So enter the cursor in the field by changing the variable cells, and when it starts blinking, select with the mouse arrow cell F23. You might have to move the solver window a little. Keep in mind what we're trying to do. We're seeking the required margin that, when used to discount the scheduled cash flows, coupons, and face value at maturity, we get a bond value equal to the bond quote of 98. Now, go down here where you can see Solve and press it. Solver changes the required margin until it finds, in the objective cell, the difference between the bond price and the sum of present value cash flows. A value that is approximately 0. And then prompts you with this window here. You simply press OK. Look in cell F23. What we've got, 204 basis points. Investors demand a required margin greater than the quoted margin of 100 basis points, and this is reflected in the market price, which is below par. When this floating rate note was issued at par, investors then required at that time a spread of only 100 basis points over the market reference rate. Now, why do investors demand a higher required margin over the market reference rate? Most likely because the credit quality of the issuer has deteriorated. Perhaps the issuer is even being downgraded by credit rating agencies. This floater trades at a discount because the quoted margin of 100 basis points is deficient by 104 basis points. It asked the difference between our estimated required margin of 204 and the quoted spread of 100. The changes in the required margin usually come from changes in the issuer's perceived credit risk. Also, changes in liquidity or taxation can affect the required margin. These are the same factors that affect the yield spread for fixed-rate bonds. Now, we can practice a little by going a little further. If you take a look at the equation we used so far, you will notice that the discount rate per period in our example, coupon payments were semi-annual, so the discount rate we've just seen in column H is semi-annual. And if we keep using our simplifying assumptions we mentioned at the beginning, we can use Excel's rate function to back into the required margin given the market price, without using GoSeek or Solver, as we've just seen. We have the coupons in the numerator, 1.25%, plus the quoted spread of 1%, paid semi-annually. We have the future value at redemption, 100. We don't have the discount margin, or rate. We can use the rate function. As you can notice, I've already done this in cell H49. Go to Formulas, choose Financials, and then pick Rate by entering the arguments into the function. NPER is the number of periods or the product of time to maturity in years and periodicity of the coupon payments. In this case, 2 times 2, or 4. Then PMT for payment is the coupon that is 2.25% divided by 2. Then PV for present value, which is our market price. Make sure to enter the market price. In this case, it's the value in cell H47 with the negative sign. This is important since Excel will be seeking an internal rate of return. And then in cell H44, we have the future value, that in our case is the face value. Press Enter, and we get a discount rate of 1.646%, represented by rate in my spreadsheet. Now, if you look at this inversion formula that I've pasted on the right, the required margin Q is given by the product of the discount rate, rate, times the periodicity, M, minus the market reference rate, R, in this case Euribor, and we get 2.041%. The same result as before when we used Solver. Please note also that I replaced our previous notation with the one that Excel uses. The discount rate R plus Q divided by M has become rate. The coupon payments have become PMT. The face value of 100 is now FV for future value. The market price is PV for present value, and the number of periods is NPER instead of N. I wanted to show you what the formula rate does. Before wrapping up this lesson, I would like you to notice that if we go back to our first example, when we used Excel Solver, if we assume the market reference rate changes, as I'm demonstrating now, I can change this rate as much as I want, more or less. But the sum of the cash flows in present value changes little, if any. This is one of the important features we mentioned at the beginning of this lesson. Floating rate notes are less sensitive to interest rate fluctuations. And the reason is that when interest rates change, the floater coupons change in the same direction. If rates go up, then the coupon goes up. If rates go down, the coupons go down as well. If you change the required rate instead, if you raise it, the sum decreases and vice versa. Let me give you a brief summary of what we just seen in this lecture. A floating rate bond or note is a security with interest that's determined by two components: an observable market interest rate and a quoted margin. The market reference rate can be Euribor or SOFR or SONIA rates. These are some current alternatives used as market reference rates that have replaced the now retired LIBOR. Coupon payments are reset periodically on predetermined dates and capture changes in the market reference rate. The quoted margin is a stated specified spread over or under the reference rate, whilst the required margin or required spread or discount margin, is the spread required by investors and that compensates for other factor risks, most notably credit risks among these. When a floating rate note trades at par, the required margin equals the quoted margin. When the security trades at a discount, the required margin is greater than the quoted margin. And when the bond trades at a premium, the required margin is less than the quoted margin. We don't observe the required margin. We infer it from the floating rate bond price. When investors demand a higher required margin, they show it on the lower price they're willing to buy the bond. And vice versa. If the required margin has decreased, it's because the bond price has increased. Be sure to complete the questions at the end of the lesson to solidify your understanding. Also, don't forget to download the slides, the spreadsheet, and the notes if you haven't already. They will be extremely helpful for your study and review. I'll see you in the next lecture about the yield curve and more specifically, spot rates.